Unveiling the radio silence above, a satellite's tale from 36,000 kilometers up. The night sky, a canvas of infinite wonder, is under threat from an unexpected source, radio emissions from satellites in geostationary orbit. While the low Earth orbit satellites like SpaceX's Starlink have been in the spotlight for their impact on astronomy, a new study reveals a different kind of pollution from these distant neighbors. Imagine a satellite, 36,000 kilometers above the Earth, frozen in one spot in the sky. These geostationary satellites, designed for tasks like television broadcasts and military communications, have been a silent sentinel in the heavens. But are they leaking unintended radio emissions that could interfere with the delicate work of radio astronomers? A team of researchers from CSIRO's Astronomy and Space Science Division has finally answered this question, and the news is mostly positive. Using data from the GLIMEX survey captured by Australia's Murchison Widefield Array in 2020, they analyzed observations in the low-frequency range of 72 to 231 MHz, crucial for the upcoming Square Kilometre Array, SKA. The results were remarkable. The vast majority of these distant satellites remain invisible to radio telescopes in this frequency range. For most satellites, the team established upper limits of 1 mW of equivalent isotropic radiated power in a 30.72 MHz bandwidth. The best limits reached an impressive 0.3 mW. Only one satellite, Intelsat 10-02, showed a possible detection of unintended emission at around 0.8 mW. Even this potential culprit remained well below typical emission levels seen from low Earth orbit satellites, which can radiate hundreds of times more powerfully. The distinction matters because of distance and geometry. Geostationary satellites are 10 times farther from Earth than the International Space Station orbits. At that distance, even relatively strong radio emissions fade to faint whispers by the time they reach telescopes on the ground. Moreover, the study's observation strategy, pointing near the celestial equator, meant each satellite remained in the telescope's wide field of view for extended periods, allowing sensitive stacking techniques that would reveal even intermittent emissions. The SKA, a massive radio telescope project in Australia and South Africa, will be orders of magnitude more sensitive than current instruments in the low-frequency range. What appears as harmless background noise to today's telescopes could become devastating interference for SKA. These new measurements provide crucial baseline data for predicting and mitigating future radio frequency interference. As satellite constellations proliferate and radio telescopes grow more sensitive, the pristine radio quiet that astronomers have long relied upon is slowly vanishing. Even satellites designed to avoid certain protected frequencies can leak unintended emissions through electrical systems, solar panels, and onboard computers. For now, geostationary satellites appear to be respectful neighbors in the low-frequency radio spectrum. But as technology evolves and traffic increases, will they remain so? Source: Limits on unintended radio emission from geostationary and geosynchronous satellites in the SK low-frequency range. https://oxford.org/apps/2512.07341